Today, we're going to do something a little different, a book review, but we're not talking about some new bestseller. We're diving into a text that's over 1,000 years old, and it might just be one of the most important books ever written. Why? Well, because it gave us a completely new language to describe the world. It gave us algebra.
But before we even crack this thing open, I want you to just think about this for a second. How would you solve a math problem without the symbols you use every day? No X to represent the thing you're looking for, no plus sign, no equal sign. It's kind of mind-bending, right? A simple problem suddenly becomes almost impossible to even write down, let alone solve. Well, that was the world before this book. So, what is this revolutionary book? It's called the Compendious Book on Calculation by Completion and Balancing. Yeah, it's a mouthful, I know, but it does exactly what it says on the tin. It's a complete guide to a new, incredibly powerful way of thinking about numbers.
And here it is. This is the source code. This text, written more than 1,200 years ago, is the starting point for all the algebra that every single one of us learns in school. From basic equations to complex computer models, the DNA is right here in these pages.
So who was the genius behind it all? His name was Muhammad ibn Musa al-Khwarizmi. He was a Persian scholar, a brilliant mind working at the legendary House of Wisdom in Baghdad. Now you have to understand, during the Islamic Golden Age, this place was the intellectual center of the entire world. It was the hub where all the world's knowledge was being collected, translated, and pushed forward.
And why did he write it? Was this just some abstract academic exercise? Not at all. He tells us right in the introduction. He wanted to create something easiest and most useful for the real-world problems people were dealing with every day. Things like inheritances, lawsuits, and business deals. This was math for the real world.
Okay, but here's the thing. Before al-Khwarizmi could show people how to solve equations, he first had to invent a way to talk about them. He had to create a shared language, defining the basic parts of a problem using only words. So his first building block was what he called roots, or sometimes things. Pretty simple, right? It was just the unknown value you were trying to figure out. Today, we just call it x.
The next piece was the square. Again, totally logical. It's just the result of a root multiplied by itself, what we'd write down as x squared.
And the final piece of the puzzle? Just numbers. These are the known quantities, the simple figures in the equation that aren't tied to roots or squares. We call them constants now. And that's it. With just those three concepts, roots, squares, and numbers, he could describe any quadratic equation out there.
And this is where you see the sheer elegance of his mind. Using only those three building blocks, al-Khwarizmi realized that every problem could be boiled down to one of 6 standard types. Squares are equal to roots. Squares and roots are equal to numbers. It might seem basic to us, but this was a revolution. For the very first time in history, there was a system, a playbook for solving these kinds of problems.
Now, having a system is one thing, but the most incredible part of this book is how he proved that his system actually worked. He knew it wasn't enough to just give people a recipe. He had to show them why the recipe was correct, and he did it using the most universal language there is, pictures. He used geometry.
So let's actually walk through one of his classic problems. He would state it in plain language, just like this. A square and 10 of its roots are equal to 39. Now, in our modern symbols, we would just write x squared plus 10x equals 39.
So al-Khwarizmi gives a step-by-step recipe, a verbal algorithm. Let's just follow it. First, you have the number of the roots. Okay, 10 becomes 5. Multiply this by itself. 5 times 5 is 25. Add this to the number. So 39 plus our 25 is 64. Take the root of the result. Square root of 64 is 8. And the last step. Subtract the half of the roots, which was 5. So 8 minus 5 gives us 3. The root is 3. It works perfectly.
So yeah, the recipe works. It spits out the right answer. But this is the real magic. How did he prove that this wasn't just some neat trick that only worked for this one specific problem? How did he show that this method was universally true?
He proved it with geometry. It's so cool. He starts with a literal square. The area of this shape is the square from his problem, our x square. Okay, what about the 10 roots, the x? Here's what he does. He splits that 10 into 4 equal pieces of 2.5 and attaches 4 identical rectangles to the sides of that first square. Each rectangle has an area of 2.5 times x, so all 4 together have an area of exactly 10x. Now you can see what he's built, right? It's almost a bigger square, but you've got these 4 little corners missing. So to complete the square, he literally fills in those corners. Each corner is a tiny square that's 2.5 by 2.5. So what's their total area? Well, it's 25. That's the same 25 from his recipe. This physical act of completion or restoration, that's what he called algebra. So let's just think about the total area of this big new square we just made. We know from the original problem that the middle part, the x squared and the 10x rectangles, had an area of 39. And we just physically added the 4 corner pieces, which we know have a total area of 25. So the total area has to be 39 plus 25, which is 64.
And if you have a perfect square with an area of 64, what's the length of one of its sides? It's got to be 8, right? Now just look at the diagram. The side of the big square is made up of the side of that original little square, which is x, plus 2 of those little 2.5 sections. So the total side length is x plus 5. And if x plus 5 equals 8, well then x has to be 3. The geometry proves the algorithm. It's not a trick, it's a visual, undeniable truth. It's just beautiful.
So that's the book. But what's the big takeaway here? What is the lasting legacy of this incredible work that makes it so important over 1,000 years later? Well, first of all, the very name of the mathematics he created comes directly from his book. Remember that term algebra, the word he used for the process of completing the square? When his book was eventually translated into Latin, algebra morphed into the word we all know today, algebra.
But honestly, it gets even crazier than that. The author's own name, al-Khwarizmi, was eventually Latinized to Algorithmi. And because his book became so famous for its clear, logical, step-by-step instructions, his very name became the word we use for any set of rules to be followed in a calculation, an algorithm. I mean, think about that for a second. Every time you use Google or scroll through your phone, you are literally using a concept named after a 9th century scholar from Baghdad.
So in the end, what was the book's true gift to the world? It was the very first text to treat algebra as its own field of study. It wasn't just a grab bag of tricks anymore. It was a complete, logical, and systematic way to solve problems, laid out in a way that anyone could follow.
And that's where we'll leave it. It really makes you wonder, doesn't it? What other absolutely fundamental ideas that our entire world is built on are just sitting there, hidden away in ancient texts, just waiting for someone to open them up and explore the logic inside?